Okay, afternoon everyone. Welcome along to the last talk of the day. Glad to see people are still here and still awake and not drunk. Quick show of hands. I'm guessing people have heard of Docker. Heard of Docker? Used Docker? Written a Docker file? Okay, so we've got a good variety. I first encountered Docker, it was about 2 years ago now, in 2014, early 2014. A customer asked me to do a security architecture review, and they said, where I was expecting to see virtual machines, they had this Docker thing. So I thought, what the hell is that? And I Googled it. And it was a really easy review for me because I went to Docker's homepage and it said, under heavy development, do not use in production. Free finding, great. But I thought to myself, well, hang on, if this is so cool, obviously people are using this thing, even though it's like, not even in production. So why is this so cool? Why do people want to use it? And that got me into looking at Docker. And it's kind of where this talk came from. It's from my explorations around Docker and what I found out about it over the last couple of years. So, obligatory about me, I've been in information IT security for X years, where X is a number I don't want to talk about. X minus 5 in security testing, and I'm currently a managing consultant at NCC Group. As I'm a pen tester, that means I get to work from home, so I get to live here, which is Loch Goilhead in the Scottish Highlands, which is very nice most of the year when the midges aren't here. So, what are we going to talk about today? There's kind of 3 areas to this talk. It's kind of talk of 3 parts. The first part is kind of Docker introduction, because although lots of people are talking about it, and there's a lot of companies saying Docker, 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 containers, containers, there's not necessarily a lot of information about how exactly it works and what you do with it and how it all puts together. And some of the terminology is a bit vague. So we'll do about that. Container security. So obviously we've got to talk about how this is actually secured. How does it do what it does? How does it actually work? And then I want to take a bit of kind of practical look at like an attacker and defender view. So if you're a pen tester and you come across Docker, what do you want to do? If you're trying to secure Docker, how do you want to do that as well? So, background, introduction, if you don't know this. Started in 2013, this is a relatively young piece of software, but it's really active. So their main code base has got 25,000 commits. And I've been doing this talk for 6 months, and I've upgraded that number by about 3,000. So they're going really quickly. There's a lot of big tech company interest in this. IBM have got services running on it, and Commit, I've got people who work full-time on it. Microsoft are actually writing, essentially integrating Docker into Windows Server 2016. So when you get Windows Server 2016, you can run Windows containers. I'm not going to cover that here, but they're essentially writing a whole load of stuff to make that work and contributing loads. And if you go to people like Azure or Amazon Web Services or Google Cloud Services, they've all got container services, right? So they'll tell you that you can deploy containers on their cloud. And it's involved in containerization software in a variety of ways. So the first thing to kind of cover is, well, what is a container, right? So why? And I was going to use an analogy. I thought I'll use a quick analogy of Goldilocks and the Three Bears. So if you think about the Goldilocks and the Three Bears, she had her porridge that was too cold, too hot, and just about right. If you think about how we used to run, or how we traditionally run processes on Linux, when you run a process on Linux, you run it as a user, and it has all the rights of the invoking user. So if you run it as root, the process has the rights of root. If it misbehaves, if it does something it shouldn't do, it does it with the rights of root, and it can do bad things. That, I would argue, is too cold from an isolation point of view. It's not enough isolation. So a lot of people say, well, that's bad, and we're running servers and we're running services. We're going to isolate everything. We'll put them on separate VMs, or maybe even separate physical servers. So there you get a lot of isolation. Each process or each application service has its own full operating system stack, and it's maybe even got its own hardware. It's definitely got its own virtual hardware. But with that goes quite a lot of overhead, both in terms of performance and in terms of manageability. You've got to manage all those operating system instances. So that could maybe be too hot in terms of how much isolation. It's too much isolation. And so the idea of containerization is you take a middle path. You have one operating system kernel, and everything runs off that, but you have isolation that sits there and manages to isolate each individual application process so they can't interfere with each other. But you get all the performance of not having to have different VMs or different physical hardware. That's the idea. This isn't new. It's in no way new. Linux containerization has been around since the 80s. Chroot. I mean, if you use Linux, you've come across Chroot and Chroot jails. So they presented an isolated view of the file system, and that was the first kind of containerization. And since then, there have been a variety of things that looked at that, like OpenVZ, FreeBSD jails, Solaris zones, and LXC. And the argument might come, well, why is everyone so interested in this now? This isn't new in any way, shape, or form. So I kind of, from my point of view, from my looking at it, it's really a couple of things. Docker lets you be portable, right? So one of the big problems of application development is the developer says, hey, this app works fine in my development laptop, and then you deploy it to a production server, and suddenly it doesn't work anymore. Docker kind of solves that problem in a lot of cases by bundling up all the dependencies that sit with the application and having them in a nice reproducible container that you can just deploy anywhere you like. That's the goal. Speed, you get a lot faster. It's a lot faster to deploy and a lot faster to develop if you use all of Docker's tools. And size, so compared to virtual machines, your Docker images should be a lot smaller. You can go all the way down to BusyBox has a Docker image which presents a reasonably usable Linux environment in about 1.5 meg. So it's a lot smaller than running a full VM. So there's some benefits there. And because I'm mad, I'm going to do demos. So let's try. See how the first demo goes. Okay, so what I've got here is I've got a little screen file. All this is going to do is it's going to launch up 10 instances of Ubuntu, right? And it's going to launch up bash in each one. So if I do that, right, that's on a laptop. It's running locally about 3 seconds, 4 seconds, and that's a 3-year-old laptop. This is not a brand new piece of kit with like quad core or anything like that. And I can look, and each one of these has got its own, oops, if I could type, got its own network stack, and it's got its own file system. So if you create a file on one of these, you don't create it anywhere else. And it's got its own process list, so none of these conflict. So you can see from that, you can see why developers like it, right? That's a hell of a lot easier than running up 10 virtual machines, or even worse, 10 physical servers. So that kind of gives you an idea of, I think, why people are kind of keen on this as an idea. I tend to think, I've been looking at this, and I kind of tend to think of Docker as like a kind of cornucopia, because every time I turn around, they've got a new product. When I've given this presentation for about 6 months now, and when I started off, I tried to cover all the products in their lineup, and I just forget it. I can't do that anymore. I'll be here just talking about that. So I'll talk about some kind of key ones. The first one is Docker Engine. So what Docker does is it has all this kind of containerization, but it has a Linux daemon which sits there and manages all that for you. So you have a command line or you have an API, and you send commands to the Docker engine, and it then creates images, it creates containers, it creates networks, volumes, all that sort of thing. It's a fairly big Go code base, and that's, whenever talks about Docker, and they don't say what they're talking about, they mean Docker Engine. It's called, but that's what its actual product name is. Well, actually, I'll mention this just in passing while I think about it. If you're looking more at security in Docker, be very careful about the age of the article you're looking at. Anything from more than 6 months ago is ancient times in Docker land, and probably doesn't count. They're doing one release every 2 months. So, and they put new security features into every release. So pretty much, yeah, keeping up to date is kind of key. So that's Docker Engine, and that's the main key part of it. On top of that is the other thing which makes Docker so amazingly attractive to people is Docker registry. There's a public one called Docker Hub. If you want to install a new, for example, WordPress blog, you can just go Docker run WordPress, away you go, and it will pull down all the components needed for WordPress and install them and get them running. And you just get a WordPress image. You want to do Oracle, you get an Oracle image. You want to do Ubuntu, a Debian, pretty much anything you can think of. Someone has created an image for it, put it in the App Store. So it's like an iOS App Store for servers, and you just run it, and it runs really nice, really fast. And this presentation is in the Docker Hub. So if you go looking for my presentation in Docker Hub, this is just running off a Docker image. Other thing I'd mention in passing, because I'm going to do a demo later on, is a thing called Docker Compose. So most servers aren't so simple that you can run one component and you can say, here is just a server. You might have databases, you might have load balancers, you might have lots of components. What this lets you do is say, here is a complex environment made up of multiple components. I'm going to put all these components together, describe their networks, describe their volumes, and run one command and bring the entire thing up or down, which is very handy. So, useful uses for Docker. I thought I'd quickly talk about a couple of uses which I like, which I've started using it for myself. So if you're a pen tester, like me, you might have encountered online, sometimes you'll find people will say, hey, I've got this great exploit that's totally going to get this new vulnerability, and you can totally compromise the server that you're trying to compromise on your test. You might not always want to trust them. They might not be telling you the truth. I don't know, sometimes and I've seen this, there's malicious exploits out there. So one of the things you can use Docker for is to kind of have a shot with something in a quick and easy way, isolated away from your main operating system, before you try running this in kind of a real way. So I've got an example here. I've got a script in this directory called pun.sh, which I've been reliably informed will totally exploit the target I'm looking at right now. And I can mount that inside a container. So I'm now inside my container, and I can go into script. And I can run pun.sh. And it's obviously legit, because it's got great ASCII art. And it says, please wait for punnage. And then it says, oh, it didn't work. Reply hazy, hack again later. So it didn't work. Fine. But what did it actually do? So Docker, because it's running in a container, and what it does is it has this base file system, and then it layers on your changes. They use a thing called copy on write. So they layer any changes you make to it on top of it. It's easy for them to examine that layer and say, what changed? What happened in this image? So what you can do is you can just say docker diff demo2, and that tells me everything that's changed since that image was launched. Oh, so he changed etc password and etc shadow and created something called home bob. Maybe that wasn't quite what I wanted to do. Maybe that was a bad container and a bad script. So what you can just do is just go docker rm demo2, and all that's gone. So anything that person tried to do to your machine is now gone. It's vanished off the system. And that, to me, is quite a useful technique. And the other one I've been kind of playing with and looking at is pen test environment automation. You can tell my back pen test what kind of gets my interest in these things. Sometimes I've had customers that say, you go to go on site, and they say, you can't plug your laptop in, which is kind of annoying. And then they say, but you can give us tools and we'll run them. And you think, well, okay, that doesn't make much sense to me, but anyway, that's how it works. There's a security policy in there, you can't connect your laptop. The problem with that tends to be that some pen test tools, I'm sure you recognize, aren't always the most easy things to get working properly and configure properly. So it's really nice to be able to say, well, I'll just give you a set of Docker images, you just run these, and they will give me a configured environment the way I want. And it's really easy to do. As a basic example, I've got a basic example. So I've got, actually, look at it. So this is a Docker compose YAML file, and it's really straightforward. You can see what it does. It basically says, there's my Firefox image, and I've got a burp image as well. And it gives me a little volume, so I can basically share the data from my pen test in an isolated volume and then take it away afterwards, just say, give me a copy of that volume. And it maps them all together and actually kind of like, says, okay, you two are going to work together. And those are configured the way I want. So all I have to do, again, theory, is go docker compose up. And it'll go away, and yeah, and I get a Firefox image, and in a couple of seconds, because Java is slow, I should get a burp image. Yeah, and I get a burp image as well. And those are configured with my tools, they're configured with my add-ins, the proxy is configured to talk to each other, the CA certificate's pre-configured. So in terms of creating an isolated pen testing environment, and when I'm finished, I can say, zip up the contents of those two images, and that is everything that went with this pen test. That is all the artifacts with it. If you need to recreate a finding, I can get my environment back the exact way it was when I was doing this test. Quite useful. So this is all great and super useful, but is it actually secure, right? So is it actually any use, or does it bad? So if you look for Docker security articles online, you will encounter the phrase, containers don't contain. So like Pandora's box, they let all the bad stuff out. And definitely some of the older articles went down this line of containers don't contain, you can't trust them to provide isolation. The answer is it's not quite as straightforward as that, but you need to understand how it does it to say how happy you are. First thing to recognize, container security is Linux security. There's absolutely nothing that Docker does to create a container that you can't do yourself manually with Linux commands. Same with Rocket, same with LXC, or like any of these Linux container platforms. You can do it all yourself manually. It's just really painful and really awkward, and Docker hides all that from you. How does it do it? First thing it uses is namespaces. So obviously, when you saw me running up containers there, ooh, hello, Bert. Why did you want to be on the front? You don't get to be on the front. Go away. So yeah, when you saw me run up those containers there, I had my own isolated file systems. If I'd done PS, I wouldn't have seen all the processes, I wouldn't have seen the same network stack. How is it doing that? And the answer is using Linux namespaces, which are a feature which Linux has had for quite a long time. They're adding more namespaces all the time, but the older ones have been there for quite a long time. First one is mount, chroot. So that's basically chroot. So that's what gives you an isolated file system, and it lets you see only a subset of the files that are available. It's probably one of the key ones. Obviously, if I can see the real root file system and I can see the real etc directory, I might start being able to do bad things to the host. I need to isolate that off. So almost all containers will run inside an isolated file system. One thing worth mentioning is Docker lets you turn any of this off. So if you want to, they give you like a kind of safe set of defaults, what they think are a safe set of defaults, which kind of tend more towards ease of use than security. But you can turn everything off and just say, right, I don't want to do this. But yeah. Process. If I can see the process list from other containers, we've got problems. Sometimes you'll find things like secrets inside a process. If you do PS, you might find a secret somewhere off the command line. You might find an environment variable. You might find all sorts of leakage. Also, if you're running as root inside a container, if you can see the process list, you can probably kill other processes, unless you're running user namespaces, which we'll talk about in a bit. So obviously, isolating process lists is really important. And isolating the network as well. You don't want to be running the host's network stack, because then you get the same local host interface. And as we've seen, probably if you've done Linux security, or any security, sometimes people will assume if you can bind to localhost and you can address localhost that you're trusted. So you don't want that. So you want to have a different network stack and have it isolated. So Docker gets its own little network, and all the containers go to live on that network. Other ones, less relevant. IPC, still need it in case you're using processes that run IPC. You can get memory clashes, so you can get people squatting on memory, so you want to give it isolated IPC. UTS is just, don't know why it's got its own namespace. Basically, it's the host name and the domain name. So basically, UTS namespace says, give me my own host name, don't use the host's one. And the last one is the most important one, and it's the newest one. So another complaint that you often see about Docker security is people saying root in the container is root on the host, which used to be true. So if I'm the root user inside a container, unless I turn this on, I am the same root user as is on the host. I'm a constrained root user, and I've got a hold of things that are stopping me doing things, but ultimately, if I can bypass those, I'm still root. The OS will treat me like root. It's very dangerous to run as root, obviously. So what you can do now is you can enable user namespace. And what that does is it says, you may be root inside the container, but in the outside world, you're this random high user, generally like UID 10,000 or something. It creates a high user at launch time for all the containers in a given image, or on a given server. It's not turned on by default. Very important point. If anyone's planning to deploy Docker, turn that on. That's like, if you don't remember anything else, there's a beery haze after tonight, and you wake up going, what did that guy say? Turn on user namespaces is what he said. Because it by far and away gets rid of a lot of the problems with container security, or makes them a lot less bad. And there's lots of ways that if you haven't turned it on, you can get tripped up. So user namespaces is a great idea to turn on. So that's all great, but what else does it do? So it tries to create an isolated view of everything. It also uses Linux capabilities. They're a reasonably new feature, and you may not have come across them in Linux. In Linux land, or Unix land in general, you used to have this concept of root and not root. So either you're root and you can do everything, or you're not root and you're heavily constrained. And this led to people doing things like set UID binaries. So we'll say, for example, a good example, the one I always use is ping. Ping is generally set UID root, which means that if you can compromise the ping binary, you're root, which is obviously not great, because ping doesn't really do a lot of very high privilege stuff. What capabilities do is they get that monolithic root privilege, and they blow it out into 40-something different capabilities. So now instead of having just root set UID programs, what you can do is you can say, give me that capability. So on latest Debian Linux, you now get ping is no longer set UID root, it's got capnet raw, which is the thing that lets you send raw packets. Auditing point, actually, if you're doing any Linux audits, and one of your audit points is always look for set UID binaries, also use getcap to find people who might have given binaries capabilities they shouldn't have. So there's one, for example, called cap sysadmin, which is basically root. So if you wanted to sneakily create a file and have it give more privileges than it should have, give it cap sysadmin, and away you go. They're very useful for that. And what Docker does is it has a default set of capabilities. So they've said, here's a whitelist, here's the default whitelist. If you can go up or down from that, but we're going to give you this. They do things like give capnet raw, which can be a bit dangerous for denial of service and other purposes. So again, if you're deploying Docker, it's worth looking at, can you remove capabilities from the base image? Can you actually lock that down a bit further? Because otherwise it can get a bit dicey. Cgroups. Another problem with running all your processes, say you're running container as a service. So IBM and other companies have container as a service platforms where they will run your container on their servers. And they're obviously running multiple containers on the same VM. So they have to watch for resource management. If I can just say inside a container, hey, give me all the CPU, give me all the memory, give me all the disk I/O, and denial of service the box, that's obviously not great. And the way that gets around is there's a default set of C groups assigned. So that limits the resources that can be used by a given container. It also limits access to devices because you can't namespace devices at the moment. One of the things that people always used to say about containers is you could just do a fork bomb. So you could just run the bash script that forks off process after process after process, which was true until 1.12 when they introduced the PID-C group. So now you can't do that anymore. So you can lock that down, but they're kind of going around adding features. One of the things definitely, and this is what I was saying about versions and if you're deploying Docker, is you kind of have to keep up to date with the latest versions because they keep adding cool new stuff. And by the latest version, I mean every other month. So yeah, it can get a bit painful keeping up. What else do they do? SecComp. SecComp's really cool. So the key difference, as I said before, between VMs and containers is that containers all run off the one kernel. So they're all addressing the same operating system kernel. And the way Linux processes address the kernel is they use syscalls. So obviously, if I can make a bad syscall or I can hit a syscall that's got a vulnerability, I can try and attack the kernel and then break out to the host. And basically, if you're breaking out of containers, you do it with syscalls. You can use SecComp. SecComp is essentially a filtering system. So you can say, this container can only make these syscalls and not these other ones. Again, Docker have given you a whitelist, they've said, but the whitelist is kind of long. So there's 400-something available syscalls. They give you 300 and something by default. So it's not a greatly locked down, but you can do more than that. If you want to, you can lock it down further and say, these other syscalls you can't use. That's quite valuable to do. And the last one, you can do mandatory access control profiles. So if you got AppArmor and SE Linux, you can apply those to containers. The Docker daemon itself gets an AppArmor or SE Linux policy by default, but it doesn't do it to containers by default. So if you want to do that, you have to write your own SE Linux policies. And anyone who's done that, I think, is probably going, oh God, right now, because it's not the most user-friendly thing in the universe to have to write. And they're another level of protection, which you can add in, and they will actually sit on there and try and stop the container doing bad things. So all that's great, but it leads you to the question that will get asked all around the thing when people are talking about deploying containers, which is more secure? And the answer is, as in everything in security, it depends. If someone said to me, put a gun to my head and said, pick, I'm going to say VMs, quite clearly because they have a much smaller attack surface, right? Hypervisors and the virtual hardware that goes with them are quite small code bases, they're quite well defined, and hopefully by now they're quite well audited. The attack surface for containers is the Linux kernel, which is a big thing with lots of code in it. Not to say that, on a given day, actually, your VM might be more vulnerable than a container, but on an averages basis, I'm going to take VMs over containers every time in terms of isolation provided. But it kind of depends. But yeah, I think what I would say about the other thing about all those, I went through namespaces, C groups, capabilities, syscalls. There's a lot of moving parts there, and you have to do quite a bit of stuff manually if you want to play with it. There's not like a good security profile thing where you can say, just give it this profile. It's like, give it a SecComp profile, give it a drop this capability, add this namespace. It's a bit fiddly. So, Defender's view. You want to protect yourself from all this bad stuff. How do you do it? Docker engine security. So that was all container security, right? That was all could have applied to Rocket or any of the container engines that there are out there. The Docker engine sits there and it provides this daemon which you run against, and it's the entry point for doing anything with Docker. And there are some things to know about it. First up, it has a really kind of weak authentication and authorization story at the moment. Basically, if you're local, you either have to be in the Docker group, or you have to run sudo, or you have to run as root. If you're in the Docker group, you're root. Anyone you give Docker group access to is root, accept that fact, and treat it and manage those users in that way. Because if you've got access to Docker, Docker runs as root, and you can just run a container that says mount etc inside this and then change shadow or whatever else. Basically accept that they are root. Remotely, what they do is they use SSL certificates. So you generate an SSL certificate and you have a client cert and it connects to it. But it's the same game. By default, there's no authorization. So once you're in on a given Docker engine instance. If you give someone access to that, they can basically take root on the host without any difficulty. There is a plugin, so if you want to write your own authorization plugin, they have a framework for it, but I'm not aware. There's one, I think, that's being written. I've not seen any other ones. So what other people will do maybe is sit like a web service or something on top of that, and you log into the web service, and it maybe does your authentication piece and constrains what you can do. But by default, there isn't much. Inter-container networking. So before I mentioned that Docker gets its own little network, and all the containers live on there, by default, they can all talk to each other on any port they want, which is kind of misleading because a lot of the Docker documentation will say it's got this expose statement, which is meant to expose a port, but really you don't need it because by default they can all talk to each other. on any port. So if any of the services you're running inside Docker are making assumptions like, hey, because I'm on this isolated network, I'm secure and I don't have to worry about doing authentication, maybe you're running Mongo or something, that's bad. But you can turn that off. So you set ICC equals false, and that goes away, and then you have to explicitly say this port, this container to that container, which is a lot better situation to be in. The perils of privileged. Developers like things to be nice and easy, and Docker helps them out there because it provides a switch called -privileged. If you run privileged, you're root. Right, the container's running as root. Anything the container wants to do, it can. I've seen instances where documentation will say, in order to do this one thing, just run -privileged. Right? That's a bad idea. Never run -privileged, unless you're happy with the idea that the container is root on the host. And mounting Docker sock. So before I said that locally, if you want to use Docker, you're essentially addressing a Unix socket. People will mount that socket inside the container to do to find out information about what Docker's doing. And there are business cases where people want to do that. I've talked to developers about this, and they say, oh yeah, we do that because we have this container that does management and monitoring stuff. If you can get to Docker sock, you're root on the host because you can just run Docker commands against it. So if you get into a container and Docker sock is there, you just download a copy of the Docker binary and say, point to that and say, do whatever you want. Even if you mount it read-only. So if you mount it read-only, I did this blog post where I was like, oh, you just need to mount it read-only. And then someone said, no, that still works. And I was like, oh, I didn't really expect that. It does though, I tried it. So yeah, mounting Docker sock is dangerous, and again, something you should watch out for. If people are deploying Docker, watch out for people who want to mount Docker sock inside a container because they're basically saying, I trust this container not to do bad things. Docker Hub. So yeah, I talked before about there's this app store, which is Docker Hub, and it's really cool and it's really great, but you have to be a wee bit careful. So image provenance is really important, and it's just like if you're using open source anything else. If you're using Node or you're using Ruby or you're using Python, you have all these modules in this great app store, and you can just go install this module, and it's all great. Who wrote that module? Where did they come from? Were they secure? Were they security conscious? Did they do bad things? Were they employed by someone who maybe doesn't like your company? All sorts of potential problems, and Docker Hub is the same. They do have some trusted images, so people like Ubuntu and Debian, the OS manufacturers, have put up trusted images which are provided by them and managed by Docker. That's okay. Every other image you get, you should have a look at the Docker file and say, how is this actually being created? And a really important point is that Docker files, which is how you build a container, essentially like a bash script. They basically have commands like go and get this file, go and do this. They're iterative, so one Docker file inherits from another Docker file, inherits from another Docker file. You need to check all of them, because if somewhere halfway up that tree, someone does something really stupid, like wget a file from a random non-HTTPS source and just pipe it to bash, you could infect the entire chain of containers. If I was deploying in production, I wouldn't use Docker Hub unless I had private images, because, and I manage them all myself, because you really are trusting a whole lot of people. I would have you can get your own internal Docker registry and put your images there. Look at other people's Docker files for inspiration, but don't use them in production because they could change them. And then if you're pulling from latest, you suddenly get changed image, and it might do something you didn't want it to, and you didn't necessarily know that was going to happen. It actually happened to me with my demos today. I was doing that little demo with the fire up 10 Ubuntus, and I pulled from latest. And I didn't realize the latest image had got rid of ifconfig inside the container. And it's like, my demos failed randomly. And then I realized what happened. I was getting a later image, and they moved on to 1604 from 1404. So yeah, you have to be really careful with images. And image hardening. So one of the big benefits of containers, and one of the huge benefits of doing this, is that you are locking down the container, and you're saying, right, you get this very isolated environment, and you can't do a lot of stuff, you can't break out. People put all sorts of stuff inside their images that they probably shouldn't. They run like big 100 meg, 200 meg images. There's no need for that. You can get an Alpine Linux image, which is reasonably functional, in 5 meg. Right? So in terms of attack surface and in terms of what the attacker can do if they compromise a container, you're locked a lot down if you've got a lot less to attack with. So yeah, image hardening is important. Oh, and the other thing is patching. So you're putting all these binaries inside containers. That doesn't mean they don't need patched. The more binaries you put inside a container image, the more patching you've got to do. So the leaner the image, the less patching. Things to look for. It's really, really easy. I mean, the term VM sprawl has become a thing, and everyone knows about VM sprawl. You have to watch out that people create these VMs and leave them, and they're not there. Starting containers is really, really, really easy, and it doesn't necessarily clean up after itself. You can leave containers lying around on hosts and images lying around on hosts with redundant information, and maybe also with a running container, you did something sensitive inside that container. If you don't delete it afterwards, and you don't remember to specify the RM switch to delete, it's still sitting there on disk, waiting for someone to come along and find it. So you can easily have stuff lying around that you don't want to. Secrets management is a bit of a tricky area. So obviously, if you're starting up servers, they need to know how to do things like log into other services. So they maybe need an API key, and they maybe need like creds for a database. At the moment, that tends to be done by environment variables. So you pass in some environment variables when you launch the container. Managing and storing those environment variables is kind of important, because this is all meant to work in like automated continuous integration processes where you don't have a human sitting there typing out the password every time. It's all stored somewhere. So where that's stored and where it's coming from and how it's secured is really important. And container history. So you remember I showed you Docker diff there. You can also do Docker history, and it'll show you every command that was ever run inside that container. It's great from a forensics standpoint, right enough, but dangerous if you're leaving it lying around. You know, you've got these containers left lying around, and maybe you did something like type a password in, someone gets access to it, looks at the history, goes, oh, look, I've got a new password to play with. So definitely watch out for that lot. And tools, so there are some tools to look at this to help. So there's Docker Bench, which is Docker provided, and it's a Docker image which essentially analyzes a running Docker engine, all the containers, and looks for best practice, which it gets from the CIS guide. Interestingly, the Docker Bench, because it needs to do that, runs with all this, turns off all the security. So be very sure it's from Docker, so you probably can trust it. But yeah, it turns off all the security in order to make that work. And it gets it from there's a CIS guide, which is reasonably up to date. I think they're going to have a challenge keeping it up to date all the time, but it is relatively up to date. It's a bit wordy, but it is a good place to start in terms of like hardening information. So, attacker's view. You might be a pen tester wanting to play with these things. The first thing to look for is, so say I'm doing a web app test, and I get a shell in the box. First off is how do I know I'm in a container, right? So I've got remote code execution. What do? Look at your process list. If your process list doesn't have an init at process 1 or something like that, you're probably in a container. If you've got Apache as process PID 1, you're in a container. If you have no processes relating to hardware management, you're in a container. That's the easiest way to find out. If you guys it's a PS, which you probably do, that's well worth doing. Available programs, so if they've done a good job of container hardening, you might not have wget, you might not have curl, you might not have a lot of tools you're used to using for compromising systems. So it's well worth, if that starts happening, then you might start thinking, hey, why is there no wget? And the answer is you're probably in a container. And read-only files as root, so you might think, well, you do UID, you find out your root, and then suddenly you're finding things are read-only that shouldn't be. That's probably because you're in a container. They mount several kind of like sys, various other file systems as read-only. So you can't do the things you want to do. Breaking out. So you want to do a container breakout. The best way to do it is find a kernel vulnerability. If the host kernel isn't patched properly, or you are really cool and you have a 0-day in the Linux kernel, you can get out with that in a lot of cases, unless the syscall it uses is filtered now, or it's blocked by capabilities. So depending on how hardened the containers are, that might not be too hard. Definitely, if you look at there's a guy doing talks this year on Docker breakout and also VM breakout, so he's like saying, I can break into both. But his Docker one seems to be it's a kernel vulnerability, which he's using to break out. Mounted file systems. So you can mount file systems. When you saw me doing it there, I mounted a directory inside my container. People running containers might mount file systems they shouldn't, like /etc inside the container, which might be very dangerous. So finding out what you got mounted is a good way if you're breaking out. Docker.sock access, yeah. If they've mounted Docker sock, it's game over. You can get the host out really quickly, just download Docker and run it, and it's really easy. And container network access. So that was that bit before I was talking about where I was saying that there's this container network, and you can go around and scan around that and try and find other vulnerable hosts. That's not a bad way of doing it. Conclusion. We're on time. Cool. So yeah, in conclusion, what I would say about Docker is it is very useful, right? It's very handy. It's very convenient. The security isn't the same as running it on separate physical hosts. And anyone tells you it's as good as I personally think, not being entirely truthful, because of the bigger attack surface. But that said, there's a lot you can do to lock it down, and there's a lot you can do to make it more secure if you're worried about that. It does provide a level of isolation. As part of a kind of overall solution, it might be, and it's a good place. And realistically speaking, people are going to start using containers whether you want them to or not. If you're in security, realistically, I think trying to hold back the containerization and saying not doing that isn't going to be a winning game in the long term. So it's better to try and work out how we can actually say, okay, how can we make this better? How can we secure it more, rather than trying to say no? And the security model isn't good, but it isn't perfect yet, but it is improving. So things are getting better. They are adding new features. They are locking things down. They're giving you more options. Next, there's meant to be coming a security profile option where you can actually just say, here's a predefined security profile for my container, run this. And there's lots of potential. There's a lot of potential for actually using it in security. You start to see blog posts with people coming out saying, here's a nice way to do something complicated with pen test tools, and you can just make a container image, and away you go. There was a guided one for doing Wireshark stuff that was the other day, and it was very useful. You can just say, right, okay, I can create this image. I don't have to worry about dependencies. I mean, if you run some of the old pen testing tools, it gets like stuff written in old versions of Perl that no one uses anymore, and you can now put it in a container image and keep that there with all its very old dependencies that may be vulnerable that you don't want left lying around on your system. Keep it in a container image, and away you go. So it's a nice way to keep access to old tools as well. And lots of potential. Oh, further reading. If you want to do further reading, this has sparked off a great interest in container and container security. NCC actually have, and I know I'm pimping at NCC here, I feel bad, but they do have 2 really good white papers on this. There's one about abusing privileged and unprivileged containers, which just came out a couple of days ago, actually. And that's focusing on trying to break out and the different ways you can try and break out. And it talks a lot more in depth about how you can abuse syscalls and the various ways you can try and get out of a container. The other one is Understanding and Hardening Linux Containers, which came out April. And that's a big, long paper. It goes into a lot of the history about where containers have come from and how they've kind of developed and the different ways that you can secure them and do various things with them. And again, it kind of covers it doesn't just cover Docker, it covers like Rocket and the various competitors too. Questions? Oh, and contact details. The slides for this are on GitHub and they are on Docker. I'll tweet that out later on, so if anyone wants to just follow that or look at that, and I'll tweet it out later on. Any questions?